Was brutal in the extreme. He was a very hard professional soldier.
There is only one place in Britain where natural hot water comes pouring from the earth, and that is in the middle of the city of Bath. To the Celts, it was a sacred place, dedicated to the goddess Sulis. The Romans took Sulis and changed her into Minerva. They built hot water baths around the spring and began the tradition of taking the waters at Bath. Bath is a beautiful 18th century town built on hills which slope down to the River Avon. Its 7 hills, its streets and terraces, built in the classical style, all recall the city of Rome, which the 18th century sought to imitate. Much of Bath is built on top of the medieval town, which clustered around the abbey. But its focal point, just as it was in Roman times, is the place where the hot springs come up on the valley floor. Today's pump room buildings lie directly on top of the Roman baths. In 1979, Chronicle filmed Professor Cunliffe's unusual excavation of the Roman reservoir around the spring, built directly under the 17th century King's Bath.
Every archaeologist who starts an excavation starts with a series of questions in his mind. And my simple series of questions were, how did the Romans physically build this reservoir? How did they cope with the technical problem? How did people use it? How did they worship here, if they did? How did they throw their offerings in?
He had just 2 weeks to complete a dig that was both difficult and dangerous. The whole team had to wear protective face masks. The bug which polluted the hot springs was discovered in October 1978. Immediate safety measures were taken. In the most famous spa town in England, 250,000 gallons of hot water a day ran to waste, unused for the first time in centuries. The Bath City engineers were faced with an acute problem. Could they make the water safe and so make it usable again? The first step was to drain the King's Bath, under which the main hot spring rises, and to assess the magnitude of the task. Dotted round the city of Bath, there are other ancient baths, either built over smaller hot springs or connected to the main source of hot water under the King's Bath. These smaller baths, the hot bath and the cross bath, were found to be polluted. They were drained and shut down. The story continued to make headlines in the local papers. But there was a really shocking headline on October the 19th. The journalists had unearthed a story which the scientists had known about since July. An 11-year-old girl had died of amoebic meningitis, and there was a high probability that it was as a result of swimming in the Bow Street baths. The cause of her death was an amoeba which had escaped chlorination and lived in the Hetling spring, which bubbled untreated into the bottom of the swimming pool. The deadly amoeba was analysed by Dr. David Warhurst at the Hospital for Tropical Diseases in London. The amoeba found in the Bath Springs and in the girl's brain belongs to the species Naegleria fowleri, which flourishes in warm waters all over the world, so Bath is not a special case. It lives on the surface of mud at the bottom of water, which has become aerated.
This amoeba is a rare cause of disease. It can get into the nose when people are swimming, and it invades the brain through the back of the nose. It can then cause a very severe meningitis. Multiplication of the amoeba occurs very rapidly, and there is a very short time before death of the patient.
Just over 140 cases of amoebic meningitis have been diagnosed in the whole world since the disease was first described in 1965. The cause of the contamination was tracked down in several places in the hot water system at Bath. The amoeba is dangerous to humans when it changes into its flagellate form, in order to move out of the mud through the water to find a new habitat. The girl's death closed the baths, but Bath had already stopped being a proper spa 2 years before, when the National Health Service withdrew its financial support from the hot water treatment available there. Thousands used to flock to Bath to be relieved of rheumatism and gout, a practice which reached its modern heyday in the 1930s.
Today, the waters are scientifically adapted for health. The flow of water which supplied the Romans now supplies the great modern system of healing. Modern devices control the water. Modern medicine has devised new methods of employing their curative power. Rheumatism in all its many guises and gout are among the many complaints that are treated by the natural spring water. There are many forms of treatment, but in the healing power of this wonderful natural hot water lies in the radium emanations with which it is charged. Sometimes the waters are vaporized and the patient sits in a large cabinet, the body totally immersed in steam. Here a special apparatus is used for conveying the patient into the hot spring water for exercising partially paralyzed limbs. The baths have become a great specialized hospital.
The tragedy of the amoeba had some positive consequences. The old spa installations had already been getting rather out of date. The challenge of conquering the amoeba gave fresh impetus to the idea of making Bath a spa town again. The famous pump room, where people used to gather to drink the spa waters, was temporarily abandoned as the first stage of putting things right got underway. The fountain was stopped, and the concrete floor of the King's Bath, put over the hot spring by the Victorians, was removed. The coffee drinkers and the pump room trio, driven out by the noise, withdrew to the concert room. The people whose task it was to eradicate the amoeba and to make Bath a spa town again came together. There were structural engineers, drainage engineers, council officers, and local pressure groups campaigning for new public spa facilities. A geological consultant was called in. He worked in close cooperation with the engineers and the archaeologist Professor Barry Cunliffe.
That's in the Roman situation, but the first person to discover that there was a Roman reservoir here beneath the King's Bath was the city engineer, Major Davis. That was in 1879. He was trying to stop a leak from the King's Bath and dug a hole down into it. Now, unfortunately for us, he made virtually no records at all of his discoveries, just a few lecture notes, that's all. But his builder, the man who did all the hard work, was a very skilled artist. This was Richard Mann. And our only record of this excavation, this first excavation of the spring, are Richard Mann's beautiful drawings.
The Romans built a reservoir around the main spring of hot water, which comes pouring into the bottom of the King's Bath. From here, they tapped the water off into the Great Bath, which they used for recreation. Today, with its restored Victorian columns, this bath forms the centrepiece of the pump room complex. When Major Davis excavated around the spring, he disturbed only the top half of the Roman remains. There were high hopes of making further important discoveries in the undisturbed sediment around the spring.
We went down in the first instance to see how the spring could be cleaned out because of the wretched amoeba. But as soon as we got down there, it was quite clear that the walls which Major Davis had put in to support the floor had in fact subsided very seriously, and the floor was in a dangerous state. So the amoeba and the technical problems, the construction problems, combined to give us, archaeologists, the most amazing opportunity to do an excavation which otherwise we could never possibly have contemplated.
A number of intriguing objects had already been found in the spring by Major Davis, like this pewter mask. Perhaps there were more treasures to be found, offerings thrown to the goddess Sulis Minerva.
Because the spring is infected with these wretched amoebae, what we have to do every morning when we come in is to take off all our clothes and put on overalls and breathing masks which stop us inhaling any particles of dust. And of course we have to wear hard hats because we're down below machinery. It's potentially dangerous. The most difficult thing about this particular excavation is, of course, the water. The water is bubbling into the Roman reservoir where we're digging at the rate of something like 12,000 gallons an hour. And the most important piece of equipment we've got is a pump that can cope with it at 30,000 gallons an hour. So in theory, the pump keeps the water level down, but in practice it sometimes gets clogged. We have to shake it around, drag it out of the water, turn it off, get stones out of its innards and so on. But it is very, very important to us that that pump works efficiently. In an excavation of this sort, I very much like to take part in it and do a lot of the work myself. I have to do this anyway, because we are a small team. It never ceases to amaze me that you're seeing for the first time something that was deposited or created 17 or 1800 years ago, and it's extremely important to think about it and to worry about it all the time. And as you go, you find yourself asking yourself questions. Now, what are we doing? What are we breaking into? Are we destroying anything? We began to realize that we were cutting through a layer of box tiles, Roman tiles, which we know from other contexts were used for vaulting roofs. So it was fairly clear that we were beginning to break into a fallen roof, the roof which had collapsed down into the reservoir.
It was impossible to tell at this stage whether there were any important archaeological finds mixed up with the fallen roof, so they started sieving. For 2 days, they sieved everything from this layer of broken roof tiles and found virtually nothing.
Well, having done that, I was fairly happy whenever we came up against the broken roof to dig through it quite quickly and remove it. As soon as we got underneath the roof into the muds and the silts which filled the Roman spring and into which offerings were thrown, Then we had to go into a totally different routine. It was necessary then to sieve absolutely every bucket load of material. So a couple of us dug the material quite coarsely. We put the soil into buckets. Those buckets were taken to our 2 or 3 sievers. It varied from time to time. And everything was washed through 3 meshes of sieves. So we would pick up even the minutest thing. And this was very time consuming, but absolutely necessary. And in consequence, we have found the most, the tiniest of coins, things called minimissimi, little tiny discs of bronze, which one doesn't normally find on archaeological sites because you don't see them in the normal digging process. So I'm very confident that we have found absolutely everything that was thrown into that spring and was preserved in the layers which we have so far dug.
As the excavation progressed, some 2 tons of dirt and brick rubble a day had to be hoisted out of the dig, which was 20 feet below street level. When it was first built, the reservoir was open to the sky, but in 300 AD a brick roof was added. It was clear from the way the brickwork had fallen that it was a semicircular vault spanning 40 feet, open at the east and west to let the steam out, rather like a railway station or a glorified Nissen hut. The vault stood for more than 300 years and was seen by the Saxons before it came crashing down. A Saxon poem speaks of the ruins of Bath. Bright were the buildings, bath houses many, high forest of pinnacles, till all was overwhelmed by fate unrelenting. 1,000 years later, in 1672, the hot springs were still in use. Taking the waters had become fashionable after visits by Queen Anne of Denmark and Charles I. Samuel Pepys came here in 1668 and wrote in his diary, "He thinks it cannot be healthy for so many bodies to go into the water together." In the 17th century, they had no idea that the King's Bath was built over Roman ruins.
Those broken bits can go.
The spine of the vault and the heavy brick ribs eventually had to be removed from all over the site before the team could get at the silt underneath. The removal of the brick arches revealed for the first time the nature of the ground at the mouth of the spring. To establish this precisely was an essential preliminary to any modern engineering works.
Well, in a moment, Geoffrey, pump permitting, we'll actually go down and look at things. But if
Halfway through the dig, Barry Cunliffe called on the advice of Dr. Geoffrey Kellaway, the geological consultant to Bath City Council.
Well, first of all, there's the Roman reservoir, which is more or less this shape. The Roman baths are there, and a massive stone wall was put around the spring in the Roman period. Something like that. And there are blocks of masonry in it, which need not concern us at the moment. But if I can build up the story from the beginning, before this reservoir was built, it looks as though we've got some sort of valley coming through like this. This is the slope of the valley here, with the ground sloping down. This is a gravel bank. And I think one of the questions that we very much want your opinion on is what this bank is made of and how old you think it is.
I see, yes.
And also we've got some large blocks of stone poking out of it here. Now, to me, they look as though they're deliberately packed along the edge of the valley, but you might think that they could have got there naturally, but
yes.
perhaps we'll see this anyway.
Yes.
So this is way before the Roman period, a gravel bank there, I suppose another one there, and the main spring comes up there.
Yes.
Now, what I was wondering was, knowing that there are other springs, a crossbar spring and so on there, whether, in effect, we've got a natural flow across the site, like this, down to the river, joining all the springs up.
Yes.
And we found one side of that valley.
Yes.
Well, then the valley gets chocked with a certain amount of mud. And this is particularly interesting because we're finding flint implements in it that go back to Mesolithic period, about, 8,000 BC.
Yes.
So people were camping around the spring on these banks,
Springs, yes.
chipping their flints, making their implements, dropping them into the mud. When the Romans came, this was more or less what they saw. And their problem was to contain as many of the springs as possible. So what they did, it was quite a remarkable piece of engineering. They bung piles in right across this valley here, wooden piles, timbers about a foot across,
yes.
rammed right down at least 3 feet into the mud, and they did the same here, right the way across, through the mud. They didn't bother on this bank because the bank was solid enough.
Yes.
And having created this great piled raft all the way around, they then put their concrete on it, and then built the enclosure wall. In that way, contained the main spring, the big spring in the centre,
yes.
and there's another spring there, and there's another spring there.
Yes.
It looks as though they were trying to enclose them all.
This group.
It was an intriguing moment for Dr. Geoffrey Kellaway. He'd done a thorough geological survey of the whole of the West Country, but as Bath is so built up, he'd never known for certain what kind of ground the hot water sprang from.
Slope, you see, is exactly as we found it, just by peeling off the mud. And this, to me, as an archaeologist, is the natural. It's untouched. Now, what is it to you geologically?
Well, it looks like gravel, obviously, but, is it disturbed?
Well, it's got all these big stones in, and I think one of the possibilities, just one of the possibilities, that it might have been built up artificially in the Iron Age or something of that kind, as a revetment. You see, these stones look to me as though they, although they're natural stones, as though they may have been packed there to keep the bank up.
Yes. Yes, that is possible. One of them looks like Carboniferous limestone, so I think that probably some of these stones could have been out of the drift deposits anyway.
That's the superficial
the
stuff.
gravel, yes.
The gravel all over.
It's very coarse, this gravel, in the Bath Valley and the bottom of the valley, and they're by no means unusual for size, you know.
Mm-hmm. And then you can see over here exactly what the Romans did. This is the Roman reservoir wall. Everything up to that line is Roman structure.
Yes.
And this is the Roman concrete.
Yes.
But the Romans had the problem. They had a good solid foundation here, obviously, on the gravel.
Yes.
But just valley deposits, mud.
Mud
over
in
there.
the bottom,
yeah.
yes.
So they rammed these huge, great piles down through the mud.
Yes. Well, that certainly does suggest that this is a natural profile. I must say, I think so, yes.
But why does all this hot water come up precisely on the valley floor of Bath? The water at Bath is of atmospheric origin. In other words, it once fell as rain on the surrounding upland areas and found its way deep into the earth. Geological formations, like the clay of the Somerset coalfield, prevent this water from reaching the surface, so it has to come up where there's no clay, or where there are fissures in the clay. Now, there's a wide band of geological faults running through Bath in a north-south direction, and another band of faults running from west to east. The two areas where hot water rises are where these fissures coincide. At Hot Wells in Bristol, and on a much larger scale, the floor of the valley at Bath. The temperature of the earth is 10 degrees centigrade at the surface, and it increases by 10 degrees for every 400 meters of depth, so that at 2,000 meters, for instance, the temperature is 60 degrees centigrade. In cross-section, the geology of the Bath area looks like this. A layer of impermeable clay on top and a layer of shale at the bottom do not let the rainwater through. It's through the limestone and sandstone layers that the rain filters. At Hot Wells, Bristol, the water flows at only 24 degrees centigrade, but at Bath it gushes at 46.5 degrees, nearly twice as hot. The water's high temperature at the surface means that it must rise up very rapidly from a great depth. The 250,000 gallons of water a day that pour out at a constant pressure and a constant temperature proves that the underground system that produces it is vast. As the water flows through the rocks, it picks up dissolved chemicals from them. Many people have tried to discover the secret healing ingredient in the mineral water, but modern chemical analysis is interested only in fingerprinting it, to find out where it's been and from what depth it has come. Dr. Mike Edmonds, hydrogeologist at the Institute for Geological Sciences, sampled the Bath Springs over a period of nearly 2 years.
The composition of the Bath Spring appears to have remained constant over a long period of time. It contains some 2 grams per litre of dissolved salts, the principal salts of which are calcium and sulfate. But it is really the minor and the trace elements which provide the greatest clues to the origins of the water.
By measuring the sodium, potassium and calcium levels in the water, it's possible to calculate the temperature at which these elements dissolved, and hence the maximum temperature which the water reached deep in the earth.
We aspirate our sample of water into the flame, and the amount of light that is adsorbed in the flame is proportional to the concentration of the element in that water. So we find that the most likely maximum temperature at depth for the Bath water is 80 degrees centigrade, even though when it discharges at the surface it is now 46.5 degrees.
The sophisticated machines of modern geochemistry have analysed trace elements in the water that the chemists of the 18th and 19th centuries never dreamt of. Lithium, gallium, arsenite, iodide. Do any of these explain the water's healing properties? Today's scientists are sceptical.
To the best of my knowledge, there's nothing in this water that really gives it any medicinal property. In my opinion, most of the therapeutic value of the Bath Spring is based on its temperature and has nothing to do with its chemical composition.
The fashionable crowds of the 18th century, and the doctors who made money out of them, thought otherwise. The great controversy in those days was whether the waters contained sulphur. Whichever side of the argument the doctors supported, they still prescribed the water in large quantities, both for external and internal use. In the 18th century, drinking the water was considered more important than bathing in it. Today, the only place in Bath where water is used for therapeutic purposes is the Royal Mineral Water Hospital, which was founded in 1742 in order to provide spa water treatment for the poor.
Cross your arms across the chest now. Good, lean back. Good.
In spite of other scientific advances in the treatment of paralysis, arthritis and rheumatism, exercising in hot water still forms an important part of the treatment. This hydrotherapy pool used to be run on spa water, but since the discovery of the amoeba, the patients have had to make do with heated tap water. Sharon Baker is a senior physiotherapist.
As far as the treatment of the patient is concerned, there's no difference between tap water and mineral water. The therapeutic part is the warmth and the exercise in the water, but some patients feel much better if they've been treated in spa water. If they believe that something's doing them good, it will do them twice as much good as if they don't believe in it.
Dr. John Andrews at Bath University has also been working on the Bath waters. He's been studying the water's radioactivity and the dissolved gases in it.
The dissolved gases enable us to say something about the age of the water. We've determined the helium content of the water, which is very high compared with other groundwaters, and this suggests that the water has been in contact with deep rocks for a very long period of time, or at least that a small proportion of it is of very great age, perhaps as much as 100,000 years old. Other dissolved gases that are derived from the atmosphere we have used to establish the temperature at which the water fell as rain. And this temperature is about 10 degrees centigrade, so that we know that it must have fallen after the last ice age, that is about 10,000 years ago. And if we compare this with the carbon-14 age determinations, which suggest that the maximum age is about 20,000 years, we come to the overall conclusion that the most likely age is around 10,000 years for the bulk of the water that now rises in the centre of Bath.
The Romans had no means of knowing the great age of the water, but they knew they were dealing with a force of nature, and they made offerings to it.
What in fact we have found, and it's something of a surprise to me, I think, is a vast number of coins. I had no idea that we would find so many coins in the first 10 days or so. We must have found about 1,000 coins. Now these are surprising because very many of them are early coins, and this tells us something about the chronology of the way people use this spring. They threw them in individually, and quite clearly in some cases they threw them in great bundles, little piles of coins perhaps wrapped in linen, and in one or two cases they seem to have thrown in a great sackload of coins. Now if you threw a handful of coins in and they hit the clay layer, which was just under the water, they actually stuck in the clay, then they were preserved from all corrosion, and you could take them out in this bright, shiny condition. Now, if they lay on the surface and didn't bed themselves in the clay, then the water, which has a very high iron and sulfur content, washes around them, and it lays down around the coin this thick layer of iron salts. And quite often we find a number of coins which have been lying together, corroded in a great mass. You can see the shapes of the coins, but they are covered in corrosion. These can be taken back to the lab. These will be cleaned off, and they ought to be as readable as the ones that were preserved in the clay.
It was on the very last day that we found most of this material here, and quite a remarkable find. The goddess obviously kept it for the last moment for us. And it gives a marvellous idea, I think, of how the Romans actually reacted to the spring. It's our link with the past. Here you can see there's a little collection of pewter vessels, probably for pouring libations for the goddess. And so that there could be no mistake at all, the Romans actually engraved the goddess's name. This one says Dei Sul Min, the goddess Sulis Minerva. Well, there would have been no doubt, obviously, to a Roman that this spring was sacred to Sulis Minerva, and they could abbreviate it. They could abbreviate it DSM occasionally, but always the link with the goddess was there. Now, in addition to items like this, we can come very much closer to the people through the lead curses which they threw in. They wanted to communicate with the goddess. Their way of communicating was getting the temple scribe, no doubt for money, to write on a piece of lead their message to the goddess. We've just started opening them and cleaning them, and we've just got one or two of them now read. This one over here, for example, has been translated by my colleague Mark Hassel, and it says, I, and then we don't know the name of the man, unfortunately, make over to the holy goddess Sulis whoever stole my cloak, whether man or woman, slave or free, on condition that when the goddess Sulis gives death to Maximus and neither allows him sleep or children, I shall give Sulis my cloak at the temple of her divinity. He has sworn this. And it's typical of the sort of petty things that were worrying people during their lives. So this collection here are documents that take us directly to the people and directly back to Roman Bath. Some of them were folded up. It was quite normal. They were just for the goddess to read, so that no one else should read them. They could be folded, wrapped, the goddess would understand, or they could be nailed, actually to fix them, fix the curse to the person who was being cursed. So a very fine insight into people. The spot, the spring, was sacred because it was the one place where the two worlds, the underworld, actually communicated with the present world. It was vulnerable. It was there that you could actually talk to the underworld.
Ever since the head of Minerva was discovered in 1727, when a drain was being dug in Stall Street, People had suspected that there might be a temple dedicated to her, built somewhere near the spring. In the cellars of the pump room, Barry Cunliffe organised the digging of trial trenches. This way, he gradually built up a tentative ground plan of the Roman building which lay to the north of the sacred spring. The discovery of large flagstones in 1979 was one more certain indication of a Roman public building under the pump room. After all the evidence from under the modern streets and buildings had been assembled, it was possible to construct the ground plan of Minerva's temple to the north of the sacred spring and the Roman baths. In the temple precinct, it was also possible to locate the position of the plinth where the sacrificial altar once stood. In March 1982, at about the time of the annual celebrations of the goddess Minerva, 2 cornerstones of the great altar were moved back into position.
Half an inch that corner then. Well, over towards me, and then take that one out. Okay. All right. Right, got him? No, he's going to go back quite a way towards you.
Over the years, 3 of the 4 cornerstones of this altar had been found. One of these is still built into the outside corner of a medieval church 7 miles away. The second was discovered in the 18th century, and the third was discovered by Barry Cunliffe in 1965.
Remember when we found this one, it was sort of up on end and lying on its side just over there. And this was the first bit that we found, digging down through the mud. And I remember feeling around here and think it was just an old lump of stone, and gradually finding all these mouldings and coming onto the leg. And then the whole thing was cleared. And it was, as we realised, there were carvings on both sides. I remember there was something almost exactly like it in the museum, and absolutely covered in mud from head to foot. I just ran into the museum to see the other one, and realised that they were absolutely identical and part of the same structure, and yet they'd been found, 250 years between. Right. Good. That's right now. Good. Well, today I see.
In 1982, a Roman libation was made to the goddess for the first time since her altar had been desecrated by the Saxons.
I hope she doesn't mind that.
10 months later, the part of the temple precinct that lay under the pump room was totally cleared. This was made possible by the positioning of steel girders to support the pump room floor above. The last traces of flood deposit from Saxon times were removed from the flagstones, and the floor itself measured. The way the flagstones had been worn down would show how the precinct had been used. For this part of the dig, the director of excavations was Peter Davenport.
Well, we've been working for about 18 months within the last 2 years or so, and we've managed to uncover about half of the inner precinct of the temple. That's the courtyard in front of the temple, including the altar and various buildings and monuments around. We've now finished. We're down to the level of the Roman paving that we'll leave, which is essentially it's the late 2nd and 3rd century state of the monument. We can't really do any more, unfortunately, not in this programme, because we're cut off from the rest of the site by the foundation walls of the 18th century pump room, which is above us, including the temple over that way, which is also cut away from the rest of the site by those foundations.
But there were enough fragments of the temple left, including parts of the pediment which used to decorate its facade, to be able to reconstruct its appearance. John Woodcock of Bath University did just that on his computer.
God. It's probably something you'll recognise. God. That's the front view.
Yeah.
This is a second view. from above and from the side.
Yes, you've chosen these viewpoints already, so...
That's right. We could choose a new one, but it would take us a quarter of an hour to get a view, and we don't really want to do that now. I have, in fact, created a number of sections through the temple, and I've got a little program here which is capable of displaying those sections one after another.
That's amazing.
This computer technique, known as solid modelling, is more often applied to engineering design than to Roman temples. Once the work of constructing the three-dimensional model on the computer has been done, it can be looked at from any angle. Chronicle commissioned John Woodcock to create a computer model of the whole temple precinct. Information was provided from the measurement of the precinct layout, as well as the walls that were still standing. The fallen stones gave some idea of the size and importance of the buildings which had once stood in the precinct. All the dimensions that could be deduced from the available evidence were fed into the computer. It took 5 days to construct the computer model. The first view shown was across the altar, looking at the temple front.
Now, what I hadn't realised with that was that from that sort of viewpoint you could actually see those pavilions or shrines or whatever they are on either side of the temple. I thought the side facades would cut those out.
Yeah, only just. The buttress on the bathhouse, of course, removes half of the left-hand one.
Yes.
The shadows are for about 11 o'clock in the morning, that sort of time. That's the exact reverse view of that, looking down from the temple down towards the entrance arch. You can just see a couple of pieces of column in the right and left-hand side of the view.
Yes.
It's a bit darker as a view than the other one, because of course the sun's now facing towards you rather than away.
I think the beauty of these two, John, is that what they show us is how carefully contrived the Roman building complex was, to give two totally different impressions. The one as you're going into the building over here, with the facades on either side and the temple glowering at you at the end, all overbearing. And then the other one from on the centre monitor here, from the temple podium itself, looking out over where the worshippers would accumulate. It takes your eye line, as it were, up a lot, as obviously it must do, and the big facades on either side fall into insignificance.
Yes. It's surprising how different the two perspectives are, I think.
It's hard to imagine, in the precinct under the pump room, that the great sacrificial altar, as in all Roman temples, once stood in the open air. The computer model can reproduce the shadows cast by the sun on the altar, centre right, and recreate the open-air feeling. The view from the top also shows the close relationship between the precinct and the sacred spring under its great barrel vault in the foreground. The doorway to the spring was up a small flight of steps. The distance from the spring, across the precinct to the great altar on the left, was only a few yards. This is a view of the altar and the doorway from further back.
I think that's particularly nice because it's the way in which that quadrifrons, that big central arch, if we've got it right, does focus everyone's attention around on that one little doorway. And that was the only glimpse anyone would have seen, of course, of the water from the whole temple precinct. You wouldn't have been able to get at the water. You would probably have heard it and smelt it, but that's all you would see there.
The people of Roman Britain could view the spring through an arch and throw in their offerings to the goddess. The arch still exists today. The King's Bath excavations are now completed, and the sacred spring has been restored to its original Roman level. But 75 metres below its surface, engineers are probing for a new way of tapping off a supply of pure water. In May 1983, a drilling rig was erected in Stall Street, and a diagonal borehole was drilled towards the fissure beneath the hot spring. The aim was to get clean, hot water, free from amoeba, for the new spa development. After 9 days' work, the drilling team struck hot water at 84 metres on the incline. Two important facts had been established about the mouth of the spring. First, that the amoeba was a surface contamination, which developed on the debris only after the water had been in contact with air. And second, that the spring pipe was full of loose gravel and sand, which would easily block a vertical borehole. So the solution to getting thermal water, which was both free from amoeba and under its own hydrostatic pressure, was an inclined borehole, which could tap off water from the fissure beneath through a clean, solid rock formation. A valve was installed to control the water at the top of the borehole. From this point, Bath City Council can tap the water when it's required. Plans for the renovation of the old royal baths have already been completed by the new Spa Consortium. The Bow Street baths next door will be turned into a 20th century high-tech swimming pool. In Bath Street, the old Spa Treatment Centre, closed by the National Health Service in 1976, is to be turned into a shopping precinct. And the old Cross Bath will be restored and roofed over by the Spa Consortium and handed over to a charity so that the poor and the sick will once again have access to the healing waters. Visitors to Bath have now returned to the pump room. Immediately beneath them is the temple precinct. In place of the priests of Sulis Minerva is a Bath City engineer, the modern guardian of the spring. '20th century technology now controls the thermal water's natural force. A hot spring, sacred to Celts and Romans, is once again the source of the spa waters of Bath.